Hello, everyone. My name is Monique Morton, and I'm the Mathematics and Computer Science Director for AdvanceKentucky. And this is the second of my set of AdvanceKentucky office hours. And we're going to talk about area, volume, and arc length for the AP Calculus BC exam. I'm going to be switching between a couple of things, so I hope that all of this works right. I've been testing it out for the last few minutes to try to make each time I do this better. If you have questions or comments, you can just see that right there. That's my hashtag on Twitter, AskMoniqueKY. I'll be checking it before the broadcast and after the broadcast to see if there are any questions. I don't know if I'm going to be able to check it during the broadcast, but I'll try. Or you can just tweet me directly at Monique_Morton, and that'll get your questions to me also. Or if you're using YouTube and you have access to the chat box, I'm going to turn my chat box on while I'm saying that. You can also use the group chat to ask questions. So why don't we just go ahead and get started? I'm going to start sharing my screen now. I think I'm going to start sharing my screen now. I don't see what I can see. Well, there we go. Okay, so area, volume, and arc length is our topic. Let's talk about what you should know how to do. So you should know how to solve equations on your calculator. Area and volume for a lot of years were almost guaranteed to be on the calculator portion of the exam, at least in free response. That's not true anymore, but it could be on your calculator part or on your no calculator part. The reason you're going to need to be able to use your calculator is to actually graph the region, and if it's necessary to use your calculator to find points of intersection so that you can set up your definite integral, you'll need to know how to do that also. The area of the region enclosed by two functions, you'll need to be able to do that on some specific interval. You might have to find the endpoints. They may be obvious. You should also know how to find the volume when a region is revolved around a horizontal or vertical line using either the disco washer method. You might have learned shells in your classroom, and that's a good thing to know. However, shells is not directly tested on the AP exam, so it's not something you need to know. Now, I say not directly tested. This is what I mean. If you're working an area volume problem and you do something by the method of shells, if it's correct and appropriate to do so, you will get full credit for it, unless it specifically says to use another method. You should know how to find a volume of solid figures with regular cross sections, squares, circles, triangles, something that'll be easy for you to take the area of. And finally, you need to be able to find the length of a curve expressed in either Cartesian, xy, or parametric x of t, y of t form. This last bullet is the only one that's specific to the AP Calculus BC exam. Everything else is also tested on the AP exam. So the first question we're going to look at is from 2011 BC3, and hopefully you got a copy of the handout from your teacher before we started doing it. If not, you should be able to follow along, get a copy from your teacher a little later. This video will be recorded and will remain on my YouTube channel, so you can always go back to it. In this question, we're given f of x is equal to e to the 2x, and r is the region between the two curves bounded by the graph of f, the coordinate axis, and the vertical line x equals k, where k is positive. And you're given a region r that on the handout is actually above, on this slide is actually to the right. In part A, we want to write an expression involving an integral that finds perimeter. Part B, we want to find the volume in terms of K. And in part C, we have problem where we need to find dv dt given dk dt and k is equal to 1/2. So I'm going to walk you through each part of this problem. And the way I'm going to walk you through it is by looking at each part of it a little separately. Let me see, make sure that you're able to see what I am working on. Here we go. So here's the problem again, so that you can follow along. This is on the no calculator portion of the exam, by the way, so there's no calculator necessary to do this problem. So we're looking at part A, and part A is where we're looking for the perimeter of R in terms of K. The thing to remember about arc length is that when you're talking about a function in terms of y equals f of x, arc length is the definite integral from a to b of the square root of 1 plus f prime of x squared dx. Now this particular region, since we want the perimeter, there are 4 sides, if you will. These 2 vertical sides, this horizontal side along the bottom, and the length of this curve. So when we want to find the perimeter of R, I'm just going to start over here on the left and go around. The length of this vertical line segment is 1, right? Because that's the point 0, 1. Plus, this length here is horizontal, and that's K, so that length is K. This length here is vertical, so it's the y-coordinate of that point, so that's e to the 2K. And now we need the length of this curve, which according to our arc length formula will be the definite integral, we're going left to right from 1 to K, of the square root of 1 plus the derivative of e to the 2x is 2 e to the 2x, and that's being squared dx. Now, luckily, it just said to write the expression and not evaluate. The exam does this pretty often, so you need to make sure that you read the directions. And I'm kind of glad because I don't really want to evaluate that integral. It looks kind of hard. If you want to go ahead and square it out, remember to square the 2 here, and this is 2 here. So if you square this, this will be 4 times e to the 4x. It's okay to just leave it the way I have it, though. There's no need to go ahead and do the squaring. For part B, we're going to take this region and rotate it around the x-axis. So if you remember, what we're really doing is taking a number of really skinny rectangles and rotating them around the axis. Let's say that this is the point xy. When I rotate that skinny rectangle around the x-axis, I end up with discs, or in other words, little flat cylinders. And for this cylinder, the radius is y, and the thickness, or the height, is dx. So the volume of one of the cylinders, I'm going to call it dv, would be pi times y squared times dx. Our same pi r squared h formula that we're used to. I haven't earned any points yet, but this is a way that you can think of how to set up your integral. So the volume is equal to the definite integral from 0 to k. Oh, I just noticed something. I made a mistake up here, right? This lower limit should be 0, not 1. I'm sure somebody's at home going crazy because I wrote a 1 there and not a 0, but it should be 0. From 0 to k of pi times y, which is the function e to the 2x squared dx. This is the important part, and this is actually the hardest part of the problem to me, is setting it all up. Now that I've set it up, though, I do need to evaluate it because it says to find the volume in terms of K, and this is still in definite integral form. There might be some debate over whether this really is in terms of K or not, but they want you to evaluate the definite integral. So I'm going to rewrite this a little bit before I integrate the integral from 0 to K. I'm going to bring the pi out and call this e to the 4x dx. Using a u substitution that I'm not going to write out right now. This is going to be equal to pi over 4 times e to the 4k minus e to the 0, which is 1. Okay. So the solution to part B is the volume is pi over 4 times e to the 4k minus 1. It said it was in terms of k, so we should have a k in there unless we have constants. For part C, we want to find dv dt, and they tell us some stuff about dk dt, and they also tell us that v changes as k changes. So for part C, I'm going to go ahead and use the chain rule. Right? dv dt is going to be equal to dv dk, since v changes as k changes, times dk dt, which they gave me. Now we did v back here in part B, remember? So all I really need to do is take the derivative of that, and luckily the integrand is the derivative. So this is equal to pi times e to the 4k with respect to k, remember? Times dk dt, which is equal to 3. So when k is 1/2, dv dt when k is equal to 1/2, this is going to be equal to 3 pi e to the 2nd power, right? Half of 4 is 2, putting 1/2 in. So that would be the answer to part C. So as we look here, we had a little bit of volume, right, in part B. The arc length part is actually only a portion of part A, but it's a really big part of part A. And part C in this question actually took me back to the chain rule. What I'm going to do now is I'm going to go ahead and share with you a little bit about the scoring rubric for this problem. Forgive me for looking up, but my screen is actually above my head, so that's what I keep looking up when I have to look at the screen, like I do right now. So here's my scoring rubric. Right? So as you probably know by now, every free response question is worth a total of 9 points. For part A, you got 1 point for that f prime of x, 2 times e to the 2x. I didn't write it on a separate line. It's actually buried in my integral, but that's okay. I would get full credit for just doing this. I don't have to write this separate. You got 1 point for the integral. That's not just the integrand, but the whole integral. And then the last point is for having these 3 things added on to that integral for perimeter. In part B, there's actually 4 points. There's 1 point for the integrand. And in this case, you should ignore the pi. The pi is going to be considered the constant, and therefore they're not going to consider that part of the integrand for scoring purposes. It's part of the answer. So e to the 2x squared, or e to the 4x, that's the first point. Your limits from 0 to k, that's your second point. Your antiderivative, 1/4 e to the 4x, that's your third point. And then plugging everything in and multiplying by pi is your last point. Now, notice I left pi over 4 outside the function. I didn't multiply through. That's okay. multiplication, distributive property, it's the same thing. Okay. And finally, in part C, that was worth 2 points. I wrote out a little bit more than they did here, but this is dV dt equals dV dk times dk dt. And so when k is equal to 1/2, dV dk is equal to pi times 1/3. Oh, you know what I did? Huh. Where I have k typed up as 3, it should have been 1/3. So that's why it says 1/3 here. It doesn't matter. The amount of work would have been the same. Let's move on. So in this next problem, which was on the Form B portion of the 2009 exam, well, not the Form B portion, the Form B exam. There used to be Form B parts of the exam, versions, I should say, of the exam that were given to students outside of the United States as their AP exam. They still get different exams. They just don't call them Form B anymore, and they're not being released. Anyway, in this question, this was a calculator active question, so you should keep that in mind. A baker is creating a birthday cake. At the base of the birthday cake is the region R in the first quadrant under the graph of y equals f of x for x between 0 and 30, where f of x is equal to 20 sine pi x over 30. Both x and y are measured in centimeters. The region R is shown in the figure above. The derivative of f is f prime equals 2 pi over 3 cosine pi x over 30. Part A is asking us for the area of the discarded cardboard if we're making this region. Part B is asking us for the volume of the cake, and we have cross sections. And part C is asking us to find the perimeter of the base, and the base is the region R that we see. Okay, so what I'm going to do here is, like before, I'm going to walk you through the problem. I don't have a graphing calculator here with me, so I'm going to kind of cheat a little bit with how to put some stuff in the calculator and just write it the way that you would write it on the exam. I have the answers, so it's not a big deal, but I'll let you know when you would need to put things on your calculator. Remember that there are 4 different functions of the graphing calculator that you're supposed to know how to do for the AP exam. 1 is to graph on any window. 2 is to solve an equation, find a point of intersection is 0, that type of thing. 3rd is to evaluate a numerical derivative. And 4 is to evaluate a definite integral. This is going to involve number 4, evaluating a definite integral. So back to screen share so I can walk you through this problem. So here's the problem again, and in part A, we want to, if they tell us that the region is cut out of a 30 by 20 rectangular sheet of cardboard. So you actually, have a piece of cardboard that's going around like this, except it's touching. And we want to find the area of this stuff out here. Which means we need the area of the rectangle and subtract the area of R. So the area of the rectangle will be 30 times 20. And I want to subtract the area of R, which would be the definite integral from 0 to 30 of f of x dx, where f of x is 20 sine pi x over 30 dx. Actually, I could have just written f of x since they clearly define f of x here, and I could use that. I just decided to write the function out. So I would suggest at this point to put the whole line in your calculator and not do it in pieces. Put 30 times 20 minus the integral. Be careful typing the pi x over 30 in. Be sure you use parentheses in getting that fraction correctly. When you do all of that correctly, you should get 218 0.028 square centimeters. They didn't ask you for units, but it doesn't hurt to write them down. Part B. So the cake's a solid with the base R, and cross sections of the cake perpendicular to the x-axis. So the cross sections are coming down like this, right? Are semicircles. So this actually here is going to be the diameter of the semicircle, and the circles are coming up out of the paper. If the baker uses 0.05 grams of unsweetened chocolate for each cubic centimeter of cake, how much chocolate will be in the cake? So this is a volume question. I need the volume of the cake and then multiply it by 0.05 grams. So since this is a semicircle, let me draw what the cross section kind of looks like. This is a semicircle with a diameter d. And d is actually equal to f of x, right? Because if this is some generic point xy up here, the length would be y, and y is f of x. That means that the radius is actually half of that. So the volume of this cake is going to be the definite integral from 0 to 30 of the area of the cross section, which will be 1/2 r squared. Actually, it would be pi, right? Pi r squared, yes? And dx for the thickness. Now, I really don't need to rewrite this over again. This f of x is the same as that f of x, and this will actually make it a lot easier to write it. And in order to find the number of grams of unsweetened chocolate that I need for the cake, I'm going to take this value and multiply it times 0.05. Again, I would put the whole integral in here. In fact, I would probably store f of x in y1 at the beginning of the problem so I don't have to keep retyping and be afraid of making typing errors when I do it over and over again. If you do all this correctly, you end up with 117.810 grams. It's 809 if you truncate instead of round. Right? So we had an area problem, we have a volume problem, all masquerading as cake. Getting a little hungry now. So part C, I want to find the perimeter of the base of the cake. So the perimeter is going to be the length of this curve going around like this, and this horizontal length go across the bottom. So the perimeter is 30. Right, that's the bottom side, plus the definite integral from 0 to 30 of the square root of 1 plus f prime of x, which they actually gave to me, squared dx. You'll notice up here, they actually gave us f prime of x. So we can set this up this way. We don't have to write the actual function since they clearly define f prime of x for us. We can just put all this in our calculator, and our perimeter would be 81.804 centimeters. 803 if you truncate. So I'm going to talk a little bit about how the points were distributed. So as you can see, we've done two different types of questions. One of them actually was without a calculator. The second one did involve a calculator. And you'll notice that even though it did involve a calculator, you didn't use the calculator that much. Most of the points for this problem were for setups and of the problem, there were only a few points assigned to getting the actual value from the calculator. So so here's my setup. It almost looks exactly like what I wrote on the paper. Here's my scoring, right? I got 2 points for the integral. So it's 2 points for the integral from 0 to 30 in part A. Like any mistakes cost you a point. And 1 point for the answer. A lot of students may not write it down this pretty. So, you know, they might have written the integral first, evaluated it first, and then subtracted it from 600. Yeah, 600. As long as we can see where they're getting the answer from, it's very important that you don't write answers alone. In a problem like this, answers with no supporting work would get no credit. Part B, here is the area of my semicircle, and I'm looking at my piece of paper to make sure I wrote down the right thing, and I did. Again, they found the integral. The integral is this part, not the number. So the 2 points are for this definite integral, and the other point is for the answer, remembering to multiply that number by 0.05. And finally, the perimeter here is 30 plus this integral, right? They defined f prime of x for us, so we didn't have to write it out and we didn't have to find it. So 2 points for the integral. That does not include the 30, just the definite integral. And then 1 point for having the correct answer. Of course, if you forget the 30, you don't get the correct answer, so that 30 is still important. What I want to do now is I want to do a few multiple choice questions with you. In your packet, if you have one, you should turn ahead to page 6, because that's where we're going to go. And I am going to switch over now to working a few of these multiple choice questions. And so you can get an answer of what they're like. Some of them are calculator active questions. I'll tell you which ones. I probably will skip the calculator active questions because I don't have my calculator with me right now. And the other ones are no calculator, but they're mixed up in your handout. So this is where we're going to go now. So in this first multiple choice question, it asks us what gives the length of the path described by parametric equations. Now, parametric arc length, as opposed to Cartesian arc length, is given to us by taking the square root of dx dt squared plus dy dt squared. Since x is sine of t cubed, the derivative of that would be 3t squared cosine of t cubed. And we're going to square that, all of that. And the derivative of y is 5e to the 5t, and we're going to square all of that. So that's my arc length expression. It's the definite integral from 0 to pi of the square root of 9t to the 4th cosine squared of t cubed plus 25e to the 10t. So my answer is C. Now, one of the things that might help in remembering this stuff is that you can think of the length of an arc as being little pieces of the Pythagorean theorem, where you'll end up with dy squared plus dx squared. And if you remember that, you can get either one of these forms for parametric or Cartesian coordinates. simply by replacing dy and dx with what they're equal to. It'll all simplify out to be the formulas that I reminded you of earlier. And number 2, we have a R, and it's a region between y equals e to the minus 2x and the x-axis for x greater than 3, and it wants us to find the area of R. E to the minus 2x is actually, instead of going up like this, it's going to come down like that. And we're looking at values greater than 3. So we want the area of this unbounded region. Now, to find the area of this unbounded region, we actually need to do improper integral. I'm going to do this off on the side here. This is number 2. We'll need the improper integral from 3 to infinity of e to the minus 2x dx. If you saw my previous streaming video on, what was it on? Methods of integration. I talked about improper integrals in that. You might want to go back over it. So this is equal to the limit as b goes to infinity of the integral from 3 to b of e to the minus 2x. I'm going to, hopefully my writing will slow down my talking. This is the limit as b goes to infinity of negative 1/2 e to minus 2x, evaluated from 3 to b. This is the limit as b goes to infinity of negative 1/2 e to the negative 2b plus 1/2 e to the negative 6. As b goes to infinity, this first expression goes to 0. The second expression doesn't change. So my answer is 1/2 e to the minus 6, which is A. Positive, yes. And number 3, we want the area it closed through the 2 curves. Clearly, this is, hopefully it's clearly this is a calculator active question. Do I have the answer to this question on here somewhere? I do not know. You're probably going to work this out with your teacher then, since I don't have my calculator at the ready and can't really work out the calculator questions. Maybe I can. We'll see what I can do a little bit later on. This is a calculator question, a noted calculator. I have something that I can do but I don't know if I can project it. The region bounded by y equals 2x minus x squared and ex, well, this one I can at least set up, right? The reason I'm not setting this one up is because I'm going to have trouble finding the points of intersection without a calculator, I think. This one is a calculator active question, but I can set this one up because I can easily figure out what this graph looks like. It's a parabola with x-intercepts at 0 and 2. And that's the base of the solid. The cross sections are equilateral triangles, so they look like this. Well, that length is y, so each one of these lengths are y. And if you bring this down so that you can get the height, hopefully you remember the 30, 60, 90 triangles. So that would be y. This would be half of y. And this would be half of y times the square root of 3. So the height is y square root of 3 divided by 2. So the volume of the solid, kind of low on here a little bit. The volume of the solid is going to be the definite integral from 0 to 2 of the area of the base, which is an equilateral triangle. So that's 1/2 of y times the square root of 3 over 2 times y dx. So that'll at least get you started on that problem. Now all you have to do is put it in your calculator and evaluate it. You might want to multiply through a little bit to make it a little easier to put it in your calculator. For number 5, give me a second. R is the region enclosed by a graph of 1 plus ln cosine to the 4th of x. The x-axis and the lines x equals negative 2/3, x equals positive 2/3. The closest integer approximation of the area. This will also be a calculator active question, not because you need it to set up, but you probably need it to evaluate the interval. I don't really know what this guess looks like, but I know that the interval is going to look like this. So you really need to just evaluate that. You could probably just make this 0 and multiply by 2 and get it that way also, because it looks like that's going to be an even function. Anyway, you get the idea, and there's my setup. I have a lot of calculator active questions on this handout, don't I? By the way, all of these problems came from old AP exams. These are from old released AP exams. So you get an idea of the difficulty over the years of how hard these questions were. So number 6, the base of a solid is a region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 2y equals 8, as you see up here. If cross-sections of the solid perpendicular to the x-axis are semicircles with the volume of the solid. So if this is the representative slice, and that's the point x, y, right? The base of this solid, the diameter of the semicircle is equal to y. And since x plus 2y is equal to 8, y is equal to 4 minus 1/2 x, solving the expression for y. So I'm not going to be able to evaluate it all the way, but I will be able to set it up. This is the integral from 0 to 8 of 1/2, because it's a semicircle, pi times the radius, which would be y, actually. It'd be half of y squared dx. Now, as long as you have this correct, you can go ahead and put it in your calculator. This 1/2 is actually inside of what's being squared. This 1/2 out here is because it's a semicircle and not a whole circle. And remember that this distance y is not the radius, it is the diameter of the semicircle. So we can finish that off with our calculator now that we know how to set this up. In number 7, we have a region that's enclosed by the graphs of y equals x and 4x minus x squared, and it's being revolved around the y-axis, and the volume of the solid is being given about this information. Hold on, wait a minute. You know what? I'm going to skip this one. Not because I can't do it, but because this one requires the shell method to be consistent with the answers provided. So I'm going to go ahead and skip number 7. I should put that in there, but mea culpa. And I'm going to go ahead to number 8. I hope you're still hanging in there, whoever's watching. So number 8. The base of the solid is the region in the first quadrant enclosed by the graph of y equals 2 minus x squared and the coordinate axis. If every cross-section of the solid perpendicular to the y-axis is a square. Right? So notice they just have you have a setup for the integral here. This could be on the calculator part or the no calculator part. Y equals 2 minus x squared would be a parabola with x-intercept square root of 2 and negative square root of 2, and a y-intercept of 2. And, we're talking about cross sections perpendicular to the y-axis this time, so they're going this way. So that's the length. And what I want to do, I think I'm just going to look at this half over here and double it. So since y is equal to 2x squared, I can solve this for x. Actually, I wrote that wrong, right? The square root, x squared is equal to 2xy. If I take the square root of x squared, I get the square root of 2xy, 2 minus y, and I have 2 halves, right? Because the absolute value of x is equal to the square root of 2 minus y, and that's why I have plus or minus the square root. So I'm only going to look at the positive square root and then double it to get the entire area. So the cross section is a square. Well, maybe I won't. Let me see. What's the easiest thing to do here? Yeah. Let's call this point xy2 and this point xy1. They have the same x coordinate but different y coordinates, right? My square, right, which is coming up out of the paper like my pen is sticking up, actually has sides of length y2 minus y1, right? All the sides are the same length. So the area of the square, would be this quantity squared. So to evaluate the integral, I can just say from -2 to 2 of the square root of 2 minus y minus the opposite of the square root of 2 minus y dy. Oh, I missed something. It was in the first quadrant. So I don't need to go from -2 to 2. I need to go from, I don't need this part, and I don't need that part. So my answer, and I need to square this because this side squared. So my answer is actually going to be B. Oh. No, it's not going to be B. My answer is actually going to be I'm going to leave that. I'm messing this up, so I'm starting over. So in number 8, I really just want what's happening in the first quadrant. This is the square root of 2, and that's 2. And cross sections are perpendicular to the y-axis. So this is the point xy. And the squares are coming out of the paper like this. And I want the volume of the solid. So the squares have sides of length x. And since y is equal to 2 minus x squared, I want this to come out to be equal to, okay, this length is x. So the length of a side is x, which is going to be equal to add x squared minus y, which is going to be equal to the square root of 2 minus y. So the area is equal to 2 minus y. And these are actually being stacked up this way from bottom to top. So I'm integrating with respect to y and not x, which is where I was messing up. The integral from 0 to 2 of 2 minus y dy. So I was right that the answer is B. I hope you were able to follow along when I corrected myself. For number 9, we're looking at arc length again, and they've given us parametric equations again. So x prime of t is t squared, and y prime of t is t. So the length of the path is a definite integral from 0 to 1 of the square root of 1 squared plus 1 squared, t squared plus t squared dt. I'm starting to get a little tired now. And that's the integral from 0 to 1 of t to the 4th t squared. For number 10, we're looking at the length of the curve from 1 to 4, and they give us the expression, and they want to know an equation for the curve. Well, this is f prime of x squared, remember? And so that means that f prime of x squared is 9x to the 4th power. So f prime of x is equal to 3x squared. So if I take so that means that f prime is 3x squared, and that means that x is x cubed plus some constant. So wait, they told me that the point 0.16 is on the curve. So when this is equal to 6, that is equal to 1. That makes c equal to 5. And so the answer is B, y equals 5 plus x cubed. I only have one more problem in this packet, and this is it, number 11. We have the length of the path problem again. Length of the path, arc length are the same thing. It's also the same thing as distance a particle travels in motions. So when I talk about parametric motion in another video coming up later in April, I will be talking about that stuff again. You should get the idea by now. You take the derivative of this, and this is going to be 3 cosine squared t times negative sine t using the chain rule. And with derivative, that's going to be squared. And the derivative of sine cubed t would be 3 sine squared t cosine t. And we're going to square that and take the square root of it and integrate from 0 to pi over 2. So I'm thinking it's this one, cosine to the 4th, sine squared t, sine to the 4th, cosine t, 2 9s. Yeah, that answer is B. Well, I've gone through all the problems in the handout now. So I am back here. I am looking at my chat link, and I don't see any questions there. I will take a quick moment and look to see if there's anything on Twitter. So just a second, open up my browser. You don't need to see it. I am just going to see if I have any questions on Twitter. And it doesn't look like I do. Let me check my hashtag. I'm looking at my tweets now. It's loading kind of slowly. And nope, nothing on Twitter. So this is the second in a series. My next video won't be for another 2 weeks since so many schools are on spring break and I have other things that I have to take care of next week. I hope you find this helpful. It will be stored on my YouTube channel and eventually shared to the Advanced Kentucky channel. Feel free to ask questions at any time. You can tweet me directly or use the hashtag that you see right there. I'm Monique Morton, Mathematics and Computer Science Director for Advanced Kentucky, and I'll see you around. Bye-bye.